effect of negative feedback on on input resistance and output resistance of current series feedback. Now in the last lecture we have seen the current voltage series and voltage shunt. Now here we will see the current series. Now let me draw the block diagram of current series. Now output side is current. Now this is the amplifier A and feedback network beta. Output side is current. Current means same current we should get means what? Series connection we have to give. So whatever the current is flowing I naught, the same current should be available at the feedback network. Now this is so that's why output side we have to take the series, and input is also series connection. Input side we are making the series connection. Now tell me, in a series which source I need to apply? In a series we have to apply the voltage source. Why? Because in a series voltages can be added or subtracted, but currents are same. So that's why here I am taking the Vs source. Now here the voltage available is Vf and here the voltage is Vi. Now with this what can we write? A is equal to output is equal to, what is the output parameter? I naught by input is Vi. Now from this what can we write? Vi is equal, I naught is equal to what can we write? I naught is equal to A into Vi. Similarly, beta is equal to what? Output divided by input. What is output? Vf. And what is input? I naught. Now from this Vf is equal to what can we write? Vf is equal to beta times I naught. And what is the input expression? Vi is equal to Vs minus Vf. Why it is minus? Because of the negative feedback. So now these are the expressions from the block diagram. Now let me draw the equivalent diagram for the amplifier first. Now for any amplifier, what is the input? Input is just a simple resistor Ri. Now output side this time it is current source. So output is a current parameter. So current source we have to take. Now I am taking the current source. In parallel resistor R0. This is the amplifier circuit. Now this is the equivalent diagram of the amplifier. For this now I am applying the input source. Input source is nothing but what? Vs I am applying. So now here Vs is applied plus minus, and Vf is the feedback network, opposite polarities. Why? Because negative feedback. Now here the voltage is what? Vi. And what is this current source? A into input parameter is Vi. Now this is a single loop. In this loop I am taking the current as I current. Now if I am looking from this point, now here what is the resistance? Resistance Ri is equal to what? Ri is equal to Vi divided by I. Vi divided by I. If after the feedback, if I am looking from this point, then that is nothing but a input resistance with the feedback is equal to Vs. Now from in this at this point, what is the voltage source? Vs. And what is the current? Current is common, I. Now if I write the expression for the input, now this is a Vi is equal to what can we write? Vi is equal to Vs minus Vf. Where Vf, how can we write Vf? Vs minus Vf is equal to what can we write? Beta times I naught. Again Vi is equal to Vs minus. So now here again I naught is equal to how can we write? A beta Vi. Now all Vi times write together and take out the Vi, then it will be 1 plus A beta is equal to Vs. Now what can we write? Vs and Vi is equal to, we can write it as Ri into I is equal to, now here Vs is equal to what can we write? Rif into I. Both sides, here it is here Vi is equal to Ri into I into 1 plus A beta is equal to, here it is Rif into I. Both the sides I is common, cancel it. So we are getting Rif is equal to Ri into 1 plus A beta. So input is a voltage source. So how much higher the input resistance, that much better the amplifier. Why? Because if more the voltage is always proportional to the resistance, if input resistance increases, then it will receive the signal from the Vs completely. So maximum signal will be available now with the input resistance available at the Ri. So that's why here this is the it should be more. With the negative feedback, further it is increasing by 1 plus A beta times. Now this is about the input resistance. Similarly, we need to calculate the output resistance. Now here I forgot to put the load. Now this is the load RL and this is the I naught. So now this is about the input resistance. Now if we need to calculate the output resistance. Now how to calculate the output resistance? What are the parameters to calculate the output resistance? So first thing is what? Open the output terminal where we are measuring the, now here I have to open this. Now what is the voltage over here? This is the voltage, here it is V naught. If I am looking from this point, this is nothing but a R naught F. What can we write? V naught by I naught. Now input side, what we need to do? We have to short the input supply. Condition number 1 is what? Make RL is equal to infinite. Condition number 2 is what? Vs is equal to 0. Now voltage source, how can we make 0? By shorting, we can make it 0. So now if I rewrite this expression again by keeping the Vs is equal to 0, then what we will get? Vi is equal to minus Vf, where minus Vf is equal to what can we write? Minus beta I naught, minus beta I naught. Now if I write the KC, if I apply the KCL at the output, now here output it is a node. Now it is not a loop, so it is a node. That's why apply KCL at output loop. Then what can we write? I naught is equal to, now it is a entering current. These two are the leaving currents. So I naught is equal to A into Vi plus, now what is the current flowing here? So this is nothing but a V naught divided by R naught, V naught divided by R naught. Now what can we write? So Vi is equal to what can we write? I naught is equal to minus A beta I naught plus V naught by R naught. Now from this expression, I am writing all I naught terms together and taking I naught out. Thereby I will get I naught into 1 plus A beta is equal to V naught by R naught. Now what we want? We want V naught by I naught. So I am writing V naught by I naught is equal to, I am taking the R naught is coming this side, R naught into 1 plus A beta. So V naught by I naught is nothing but what? R naught F. After the feedback, the resistor. So R naught F is equal to R naught into 1 plus A beta. Now with this what we understood? Output side, output resistance, this is further increased by 1 plus A beta times with the negative feedback. Now what happens if it is increased? Then whatever the current is there, that current will not flow through this internal resistance, it will flow through the load. So how much higher the internal resistance, that much lower current, that much current flows slow, means whatever the current is there, that is completely applied to the load. Now this is the effect of negative feedback in a current series feedback. Thank you.